Welcome, history buffs and mind explorers, to Brainwaves Through Time. Today, we're hopping into our mental DeLorean and setting the dials for 1879. Our destination, Leipzig, Germany.
That's right, Molly. We're going back to the very beginning to witness the birth of modern psychology with Wilhelm Wundt and the opening of the first psychology laboratory. Forget plush couches and relaxing music. This was a science lab through and through.
Exactly. Imagine a room filled with chronometers, reaction time devices, and all sorts of gadgets designed to precisely measure human experience. Wundt was a firm believer in the power of empirical observation. No armchair philosophizing here.
His approach, known as structuralism, aimed to dissect consciousness into its most basic elements, sensations, feelings, and images. He wanted to understand the building blocks of the mind like a chemist analyzes a molecule.
But this groundbreaking endeavor didn't just appear out of thin air, did it, Jason? It was built on centuries of philosophical inquiry and scientific advancements.
Absolutely. We're talking way back to ancient Greece, with philosophers like Democritus pondering the very nature of the mind and its connection to the physical world.
Democritus's atomic theory, the idea that everything is made of indivisible particles, is fascinating. It foreshadowed our modern understanding of neural processes as electrochemical interactions at a microscopic level. That's incredible foresight.
It really is. And then fast forward to the Enlightenment, with its emphasis on reason and empiricism. This created a perfect environment for a scientific approach to the human mind to flourish.
Don't forget the burgeoning field of biology. Discoveries in anatomy and physiology provided the Welcome, everyone, to another episode where we delve into the fascinating world of the brain. Today, we're going on a journey from the microscopic level of individual neurons all the way to the macroscopic view offered by modern neuroimaging techniques.
That's right, Molly. It's amazing to think that our thoughts, feelings, and actions all originate from these tiny electrochemical signals zipping around in our brains. Let's start with the basics. What actually happens at the level of a single neuron?
Well, imagine a neuron, a nerve cell, like a tiny wire. When it's stimulated, an influx of sodium ions creates an electrical signal, an action potential, that races down its axon. It's like a domino effect, triggering the next neuron in line.
And then, at the synapse, the gap between two neurons, neurotransmitters are released. These are chemical messengers that carry the signal across to the receiving neuron. They bind to receptors, either exciting or inhibiting the next neuron in the chain, like a complex series of switches.
Exactly. And the speed of these signals, measured in milliseconds, determines the speed of our thoughts, our reactions, everything. It's incredible to think about how these interactions, invisible to the naked eye, underpin our simplest reflexes to the most complex cognitive functions.
It really is mind-boggling, Molly. Now, fast forward to the 21st century. We're no longer just theorizing about what's happening inside the brain. We can actually see it in action, thanks to neuroimaging techniques like fMRI, functional magnetic resonance imaging.
Yes. fMRI allows us to visualize brain activity in real time, mapping the intricate neural networks underlying thought, memory. Welcome, everyone, to Synapse Surfing, the podcast where we dive deep into the mysteries of the brain. I'm Molly.
And I'm Jason. Today, we're joined by Dr. Eris Thorne, a historian of the mind, to explore the surprisingly ancient roots of our understanding of mental well-being. Dr. Thorne, welcome to the show.
Dr. Thorne, your work sounds fascinating. Where do we even begin when talking about mental well-being in the ancient world?
Exactly. It's easy to assume that mental health awareness is a relatively new concept.
So, the Egyptians, despite their understanding being different from ours, were already recognizing and attempting to treat what we now call anxiety or depression.
That's incredible. So, these ancient remedies weren't just folklore. They potentially had real biochemical effects.
It's amazing to think that plants used thousands of years ago are still being investigated for their effects on our neurotransmitters today.
You're bringing the biological and the historical together, which is exactly what our audience loves. Thank you. 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 Thank you.
Welcome, everyone, to Mind Matters, where we explore the fascinating intersection of science and mental well-being. Today, we're diving deep into how our biology and environment shape our minds.
That's right, Molly. We often think of mental health as purely psychological, but the reality is far more complex. It's a symphony orchestrated by biological processes, a dance of chemicals and electrical signals, a story stretching back millennia. Consider our earliest ancestors.
Navigating the savannah, right? Their survival wasn't just about physical strength, but also the capacity of their brains, nascent structures, yet possessing the rudimentary building blocks of cognitive function. How far we've come.
Indeed. And speaking of how far we've come, let's consider the influence of epigenetics. It's the study of how environmental factors affect gene expression.
Yes. That's the field showing us how trauma, stress, even nutrition can alter gene activity, impacting everything from brain plasticity to our very susceptibility to mental health challenges. It's nature and nurture constantly interacting.
Exactly. It's a dynamic interplay, a complex feedback loop extending across generations. It's not just about the genes we inherit, but how our environment talks to those genes.
So, what are the implications for understanding and treating mental health challenges?
Well, it highlights the fact that mental well-being is not merely a philosophical concept or a fleeting emotional state. It's a deeply intricate system, a biopsychosocial phenomenon underpinned by fundamental laws of physics, chemistry, and biology, shaped by history and influenced by our environment.
It's like Dr. Thorne said, understanding its mechanisms, from the microscopic level of neuronal signaling to the macroscopic level of societal influences, is the key to unlocking more effective strategies for promoting resilience and mitigating vulnerabilities.
Absolutely. And that's the true challenge and the profound reward of this field. The more we understand this intricate interplay, the better equipped we are to support mental well-being for ourselves and future generations.
Welcome to the Neuroscience of You, where we delve into the fascinating world of the brain. Jason, ready to unravel some neural mysteries?
Absolutely, Molly. Today, we're starting with the very basics, how our brains actually work at a fundamental level. It's mind-blowing how much is happening in that 3-pound organ.
It truly is. Let's talk about cells, specifically cell membranes made of lipids and proteins. These control the flow of ions, sodium, potassium, chloride, using selective permeability.
And that tiny change in ionic concentration, driven by electrochemical gradients, sparks an action potential. Explain that a bit more.
Think of it as a tiny electrical spark, a millivolt surge, the fundamental unit of neural communication. A single note in our brain's symphony.
Wow. So, it's all electrical at the most basic level. How do we get from those simple sparks to the complex brains we have today?
Evolution, my friend. Over millions of years, natural selection favored individuals with more efficient neural networks. Faster processing, better problem solving, improved memory all became advantageous.
So our brains are shaped by evolution? That's amazing.
Exactly. The very structure of the brain, its folds and lobes reflects this journey. The cerebellum, essential for motor control, has ancient roots in our reptilian ancestors.
While the prefrontal cortex, responsible for higher-level thinking, is a more recent addition. The ability to plan and make decisions really separates us.
Speaking of planning, let's move on to the chemical landscape. It's not just electricity. Neurotransmitters play a huge role.
Dopamine, serotonin, Norepinephrine, those are the messengers of our neural orchestra, right?
Precisely. Their interactions determine our mood, motivation, and cognitive agility. A dopamine deficiency can impair motor control and lead to Parkinson's disease.
And disruptions in serotonin pathways are linked to depression. So, these chemicals are incredibly powerful.
Absolutely. It's a delicate balance, a complex interplay of electrical signals and chemical messengers that creates the amazing, unique you. But that's all the time we have for today, folks. Join us next time as we delve even deeper into the intricacies of the human brain. Welcome to Mind Matters, the podcast that delves into the fascinating intersection of psychology and science. Today, we're exploring the chemical underpinnings of our thoughts and emotions.
That's right, Molly. We often think of feelings and thoughts as abstract, subjective experiences. But what if I told you they're rooted in tangible, measurable processes within a brain?
Exactly, Jason. These aren't just subjective experiences. They are demonstrable chemical imbalances, tangible disruptions in the finely tuned biochemical machinery of the brain.
And even our perception of time, which we often consider subjective, has a firm grounding in physics and neurobiology. The precise firing patterns of neurons in specific brain regions, their rhythmic activity governed by intricate feedback loops, influence our experience of temporal flow. Our perception of a fleeting moment or an eternity is, in essence, a reflection of the complex interplay between neuronal activity and the underlying physical laws that govern its function.
So, understanding the mind isn't just about understanding psychology. It's about understanding the intricate interplay of biology, chemistry, physics, and evolutionary history. It's about grasping the magnificent complexity of a system that has been refined over eons, a symphony of signals, a dance of molecules, a story written in the very fabric of our being. This knowledge empowers us to appreciate the delicate balance that maintains our mental well-being and to approach potential imbalances with a deeper, more informed perspective.
To illustrate this, let's take a journey back in time.
Where are we headed, Jason?
The story begins not in a therapist's office, but in a bustling 17th century apothecary. The young apprentice, meticulously grinding herbs, unwittingly participates in a scientific revolution. He doesn't know it yet, but the carefully measured doses of willow bark he's preparing, rich in salicin, a precursor to aspirin, are laying the groundwork for our understanding of pain and the brain's intricate response to it.
So, this simple act was the genesis of neurochemistry?
In a way, yes. Fast forward centuries, and that apprentice's rudimentary alchemy has evolved into the sophisticated science of neurochemistry.
Welcome, everyone, to another episode where we delve into the fascinating intersection of science and psychology. Today, we're tackling a topic that affects us all, pain. Jason, ready to unravel this complex phenomenon?
Absolutely, Molly. Pain is such a universal experience. Its underlying mechanisms are incredibly intricate. It's amazing how much we've learned, but also how much we still have to discover.
Exactly. Let's start with the biological aspect. Take willow bark, for example. Its pain-relieving effects come from its interaction with cyclooxygenase enzymes.
That's right. This interaction reduces the production of prostaglandins, those inflammatory molecules that signal pain to our central nervous system. It's a beautiful example of how chemistry at the molecular level dictates our experience of discomfort.
It really is. But pain isn't solely biological, is it? That's where the psychology comes in, particularly with the placebo effect.
The placebo effect is mind-blowing. A sugar pill, believed to be a potent painkiller, can demonstrably reduce pain perception by triggering the release of endorphins, our body's natural analgesics.
It highlights the intricate interplay between expectation, perception, and neurochemical pathways. The physics of this interaction, involving complex neuronal signaling, is still being unraveled.
And the speed of these signals, measured in milliseconds, underpins the instantaneous subjective experience of pain relief. It's remarkable.
Now, let's consider the historical context. Our understanding of pain has evolved alongside our understanding of the brain itself.
From ancient trepanation, surgical drilling into the skull, possibly to alleviate pressure or perceived demonic possession, to the modern use of fMRI to map brain activity. The journey reflects a shift from supernatural explanations to scientific understanding.
The evolution of our understanding parallels the development of our technologies, the precision of our tools reflecting the accuracy of our models of the mind. It's a fascinating reflection on human progress.
Absolutely. And beyond the biological and psychological, we also need to consider the impact of societal factors.
Welcome, everyone, to today's podcast where we'll be exploring the fascinating connections between chronic stress, socioeconomic factors, and mental well-being. It's a journey that takes us from modern-day struggles all the way back to the 18th century.
That's right, Molly. We often think of mental health as an individual issue, but it's so much more than that. It's woven into the very fabric of our society, our environment, and even our history.
Exactly, Jason. Think about chronic stress, a constant companion for many of us. It's not just a feeling. It's linked to a host of health problems, including increased pain sensitivity. And when you add socioeconomic factors like poverty, discrimination, and lack of health care, the picture becomes even more complicated.
It really highlights that mental well-being isn't solely an individual's responsibility. It's deeply connected to the social and environmental systems we live in.
To really understand this interconnectedness, let's travel back in time to 1775. Imagine Benjamin Franklin, a man of reason and pragmatism, grappling with a persistent melancholy.
Ah, yes. While the American Revolution was unfolding around him, he was fighting his own internal battle. It's a fascinating example of how mental health challenges transcend time.
Indeed. What we now understand as likely depression back then was often attributed to weakness of character. But we now know it stems from a complex interplay of biological and environmental factors.
Let's delve into the biology. Take serotonin, for example, a neurotransmitter crucial for regulating mood. It's synthesized from tryptophan, an amino acid we get from our diet.
So, even something as fundamental as our diet can directly impact our mental state. It's a journey that encompasses biology, chemistry, physics, history, and sociology.
It's a vast and intricate landscape.
Welcome everyone to Historical Minds, where we delve into the psychological landscapes of prominent figures from the past. Today, we're exploring a fascinating question. Could Benjamin Franklin have suffered from depression?
That's right, Molly. While history remembers Franklin as a brilliant inventor, diplomat, and founding father, we often overlook the immense pressures he faced. We'll examine how the stresses of revolution and personal loss might have impacted his mental well-being through a neurochemical lens.
Exactly, Jason. Consider this. Franklin, amidst all that turmoil, may have unknowingly altered his diet, which in turn affected his serotonin levels. Combine that with the chronic stress, the constant cortisol surge from his political battles, and you've got a recipe for a neurochemical imbalance.
And that imbalance, disrupting the electrical activity in his brain, could have profoundly impacted his thoughts, feelings, and behaviors. Let's talk physics for a moment. Our brains operate on electricity, a tiny yet powerful current flowing through neural pathways.
Think of depression as a disruption to this finely tuned electrical system. The synaptic connections, the spaces between neurons where neurotransmitters transmit signals, become less efficient. This inefficiency is a signal degradation that directly impacts cognitive function,
leading to slowed thinking, difficulty concentrating, and even those cognitive distortions that so often accompany depression. It's a truly fascinating, yet complex, interplay of biology and experience.
Absolutely. And it's important to remember the historical context. The history of understanding mental illness is a long and winding road. Franklin, despite his remarkable intellect, wouldn't have had the tools to diagnose or treat what he might have been experiencing.
It wasn't until centuries later that advancements in neuroscience and pharmacology gave us...
Welcome to today's episode, where we're diving into the science and history behind depression. We'll explore how far we've come in understanding this complex condition and what tools we use to study it.
That's right, Molly. We often think of depression as purely a mental or emotional struggle, but it's deeply rooted in the biological functions of the brain. Let's start by discussing how the brain's network is affected.
Absolutely, Jason. Depression disrupts the efficiency of this network, causing some pathways to become overloaded while others are underutilized. It's like a city's traffic system experiencing major gridlock.
And thanks to neuroimaging techniques like fMRI, which, amazingly, are based on principles of physics, we can now observe these disruptions in real time. Tell us more about that, Molly.
fMRI is truly a game changer. We can literally see the areas of the brain showing decreased activity or altered connectivity in individuals experiencing depression. It provides visual evidence of the biological impact of the condition.
It's incredible how far we've come. To think, not long ago, we had very little insight into these processes. Now, let's shift gears a bit and bring in a historical perspective. I want to talk about Benjamin Franklin.
Benjamin Franklin? An interesting choice. What does he have to do with depression?
Well, although we can't diagnose him definitively, considering the historical context and lack of modern medical understanding, some scholars suggest that Franklin may have battled periods of significant depression. His relentless work ethic and periods of withdrawal could be seen in a new light today.
That's a fascinating point, Jason. Highlighting figures like Franklin helps us remember that mental health challenges can affect anyone, regardless of their accomplishments or social standing.
Exactly. And the story of Benjamin Franklin's potential struggles highlights the complex interplay of biology, chemistry, physics, and history in understanding mental health. It underscores how much we've learned and how much remains to be discovered about the intricate mechanisms that govern the human mind and its susceptibility to illness.
So, the next time you feel overwhelmed, remember the silent battles fought within even the brightest minds throughout history. It's a testament to the enduring complexity of the human experience.
Thank you for joining us on this journey through science and history. We hope this episode has shed some light on the multifaceted nature of depression and the importance of understanding it from various perspectives.